Hello, so this is section 2.5, guys. 2.5 is proving statements about segments and angles. Man, this is where geometry gets real, okay? What the heck is even a proof, right? We need to figure that out. That is what this whole section is about. Actually, it's probably what the rest of geometry is going to be about, so get ready. It's going to be awesome. In this section, we're going to be writing two-column proofs. And we are going to be working with properties of congruence, which we've been working with in 2.3 and 2.4. So have those notes out because it's really going to help us with this section. Okay, so let's get into this, guys. What is a proof? Okay, a proof, here's your definition, is a logical argument that uses deductive reasoning to show that a statement is true. Remember, deductive uses definitions and facts, right? So we are using deductive reasoning to show that a statement is true, okay? Why do we even need to write proofs? What are we doing, right? We already know the answer. It's pretty crazy, right? We do all of this work. We already know what the answer is when we do proofs. So what's the point, right? The point is to determine how the answer was obtained, okay? We actually, because we already know the answer, I'm going to go step by step, just like if we were little investigators, you know? How did that crime happen? How did they get that answer? Okay, and our job is to justify that each step with a true fact. Okay, so every step they go through, I need to hit them with a fact using deductive reasoning. Okay, how do we write proofs? Now that we figure out why we do it, how do we write proofs? So there's 3 different ways actually that you can write proofs. We can write them in two-column form, in paragraph form, and in a flowchart. Here, guys, in geometry, in this geometry class, we are going to focus on two-column form, okay? What are those 2 columns? Okay, the left column is the statement, and the right column is the reason. Okay, so in the left we have our work. Okay, this is the work that we're doing, and on the right we have why we are doing that work in a very logical order. Okay, the first statement and the last statement are the easiest ones because we already told what they are supposed to be. The first statement is always the given statement. In these proofs, we're always given something is true, and that's always our first statement. Our last statement is always what we want to prove to be true, okay? The last statement is what we have been working so hard to try to prove. That's what our last statement in the proof is. And that'll make more sense when we do our first one. The reasons, right? The reasons in our right column. What can those reasons be? Now, those reasons can be given information, what we're given is true, definitions that we've been learning so far, properties and postulates that we've been learning so far, and theorems, okay? And what are we doing all this work to prove? We can prove tons of things. We can prove algebraic facts. That's what we're going to start with. Those are our favorite. We are going to prove geometric and algebraic facts together. Those are also pretty fun. And then in 2.6, we're going to do geometric theorems. Okay? Tons of things that we are going to be proving. So let's get started with our very first one, algebraic facts. So here we go, guys. Look how exciting. We are writing our first two-column proof. Oh my goodness. Okay, notice, guys, with every single time you prove something, you're in the middle of a two-column proof, you're starting one. This is the format, the template, right? It's always something's going to be given, and there's always something going to be that you have to prove. And this is like this little T-chart that you want to have in your notes, your statements on the left and your reasons on the right. And what they said to start always with the given statement. So here's my given. 3 times x plus 6 plus 2x equals 33. The reason we write, that's what was given, okay? And we're going to start to solve it because it's an algebraic proof. So pretend this was back in Algebra 1, Algebra 2. How would you solve this? You're probably looking at that 3 and you want to distribute it, and that's the right move. And what's your reasoning? The distributive property, okay? These ones are pretty straightforward when we do algebraic proofs. The next thing you guys would probably want to do is combine like terms, right? 3x plus 2x We can combine those. Your reasoning is to simplify, right? Let's simplify that equation because we're trying to solve for x. What would you do next? Hopefully you're thinking that 18 you want to subtract to the other side, and that's what you're going to do. And your reasoning, guess what? The subtraction property, oh my goodness, right? It makes sense. That's your reasoning. What do you want to do next to get this x alone? Divide both sides by 5, right? To get your x equals 3. Guess what, guys? That's called the division property, and that's your final reason. And notice what they said, your last statement will be what you're trying to prove, which was true. So check that out. First one was your given, last one was what we were trying to prove right here. Okay, so that's what an algebraic proof looks like. Those will be probably the simplest for us to start off with. Okay, let's do another one, but guys, this time we're going to throw in some geometry. Okay, here is a geometric and algebraic proof. The given statement in this one, it says T is the midpoint of SU. The reason, it's given. Okay, now we have to start to think about what this statement tells me. So what does a midpoint tell me? A midpoint tells me it creates two congruent segments. Those are my tick marks. Okay, and that's what my next statement is going to be, that ST is congruent to TU. And why that's my next statement? That's the definition of a midpoint. It's in a logical order because my previous statement was about a midpoint. So now work with that fact about a midpoint. Now we know about, what do we know about congruent segments? Well, congruent segments are equal. Okay, and that's what this next line is. This should be an equal sign. ST equals TU. And that's because the definition of congruent segments. The definition of congruent segments tells me that those segments are equal. Remember, well, look what I'm trying to prove. I'm trying to prove that x equals 5. So let's start to use these expressions. So let's write now that 7x equals 3x plus 20. Now, why did I know to do that? I knew to do that because of the substitution property. Because ST is 7x and TU is 3x plus 20. So all I did was substitute 7x in for ST and 3x plus 20 in for TU. Now we can start to solve this for x because that's what I'm trying to prove all along. Okay, I'm going to combine my x's, so I'll move the 3x over. Okay, and I move that over by subtraction, right? So that's the subtraction property. And lastly, we can do division, and there's my division property. Notice I can end, I know I'm done, when my last statement is what I'm trying to prove. Okay, so there we have our first one where we mix the geometry and the algebra together. Okay, guys, you'll get the hang of these. I know you will, don't worry. This next one we're going to do is all geometry. In this, we're going to start off, they're going to be given, the statements are going to be given to us. Okay, and all we need to do is come up with the reasons. Now let's break down the given and the proof here. They're telling me, they're straight up telling me here, AC, and we'll label AC is equal to BD. Okay, they're telling me that those two segments are equal. They want me to prove that AB is equal to CD. Okay, they already have the statements there. We just need to explain it in the reasons. Okay, we know the first thing they started with was the given, right? They told me AC was equal to BD. Now what they did, notice they broke down it a little bit. They said AC was equal to AB and BC. Okay, and they did the same thing for BD. They said BD equals BC plus CD. What is that called, right? When we add the segments together that make up the entire segment, we know that, guys, that's the segment addition postulate. Remember that from chapter 1? When I'm adding those segments, that's the segment addition postulate. That's what they did in step 2. Now what they do, examine this, guys. Really look at this. They then have AB plus BC equal to BC plus BD. Okay, what they did there was the substitution property. How do I know that? Notice in my original, they took AB plus BC and substitute it in for AC, and then BC plus CD and substitute it in for BD. Okay? And now, how did they go from 3 to 4? Notice that BC is gone, right? So they subtracted the BC from both sides using the subtraction property. And I can stop there because my last statement is what I'm trying to prove. Okay, so using what I know, guys, literally we use that segment addition postulate which we've been working with. I know the substitution property, okay, using my given statement, and then ended with the subtraction property. Okay, here that's your first example of the geometric proof. Let's practice with one more. One more for 2.5. Again, they give us the statements already. We just have to explain them. Okay, so here we go. Given, I like to always mark, so you can draw it in your notes too and mark it. They're telling me that AB is congruent to CD. They're already telling me that. But then they want us to prove that AC is congruent to BD. Kind of the reverse, right? Kind of the reverse of the last one. Okay, so we know they always start off with given. This is easy, guys, so an easy way to remember it. We can always go from congruent statements. What do I know about congruent statements? They're going to now be equal, right? Segments that are congruent mean that they're equal. And that reasoning is definition of congruent segments. So AB is congruent to CD means that AB equals CD, okay, which they told me. So now let's break this down. What did they do here? Notice now I have AB plus BC, CD plus BC. What they did was they used the addition property. They just added this BC. They added that piece to both segments, giving us ultimately what I want to prove, AC and BD. So what they do next, after they added BC to both sides, then they created that AC, right? Then they said, okay, well, AB plus BC, put those two together, gives me AC. BC plus CD, put those together, gives me BD. What is this called that we know when we add two segments to give me the whole? The segment addition postulate. Okay, and then what did they do, right? We're just breaking down each step by step. What they do now, well, first I had the two segments adding to each other equals the other two segments adding to each other equals, add them together to give me the total segment. Oh, look at that. There's the substitution property, right? They just substituted AC and BD into my step 3. Okay, and now we go backwards. As soon as we can say something's equal, then we can say that by the definition of congruent segments, they're congruent. Again, there's my proof of what I was trying to prove the whole time. Okay, using those statements, those reasons that we've been working with. Okay, guys, I know you guys can do this. It's going to take us a little bit to get the hang of it, but we can do it. The more practice, the more we do the proofs and we understand them, the better we are going to get. Okay, so keep on jotting these down. Bring any questions to our Zoom. You guys rock and you guys can do this. Awesome job.